All right, everyone. Welcome to our third seminar. We have an exciting topic today. I hope this is something that will be super useful to you in your research. Environment modules are something that I use every time I log into the supercomputer, and it's definitely something that can be tricky at first. So I hope that our discussion today will be helpful to you in your research. Just a few things as we get started. Feel free to ask any questions you have in chat. You can also ask questions by unmuting yourself and asking verbally. Just keep in mind that our seminar will be recorded and archived to YouTube. So if you want to ask questions verbally, that'll be part of the recording and also be uploaded. Without further ado, let's get started. Our agenda will go like this. We'll have some discussion about some important background knowledge about why environment modules are required to get the supercomputer, to get all of the software on the supercomputer working together. And we'll also talk about um, what environment modules are and how they solve different problems for us. From there, we'll talk about finding modules to load. We'll go through and demo how to load modules, how to load lists or groups of modules, and even setting some default modules for you that'll load automatically when you log into our systems. And we'll leave off today with a short introduction to how to make your own module files. It's definitely something that is helpful for some research groups, and so we wanted to make sure we included that today. Let's get started by talking about something that's super critical to understanding environment modules, and that's by discussing environment variables. Environment variables are part of the underlying operating system we use here at Research Computing. It's going to be part of any Unix-based operating system, so any Mac or Linux machine, including a lot of smartphones, they're going to all have the same concept in their operating systems. And it's also something that you see in Windows, actually. So environment variables communicate information to programs that are running. You can set them in Bash by using the export command, and you run that by setting export variable equals value, just like I've got illustrated there on that slide. It's pretty common to set up environment variables and to want them to be consistent from login to login. If that describes you and your use case, feel free to put those export commands into either bash profile or bash rc, and that way they'll get run every time you log in or spawn a subshell. For our discussion today, we're going to mainly be talking about a very few very critical environment variables. Path is definitely one of them, along with LD library path and LD run path. Path is the environment variable that a shell will search to find different programs. So that's what allows you to say run Python instead of the fully qualified path to the Python executable. LD library path specifies where the operating system should load shared libraries from. And LD run path is important. It's a little bit more nuanced though, and we'll talk about it in just a second. The other thing we want to make sure we understand is the notion of ELF binary files. ELF is a file format that Linux uses. It stands for executable and linkable format, and it represents compiled code in a machine format. ELF files can either represent a self-contained program, something that's executable, or be a library and only part of a program, the linkable format part. ELF files have some important header information that we really care about and matters a lot to environment modules. The real big thing is that ELF files have something called rpath and runpath. Rpath is old and deprecated, but is still used quite frequently. Runpath is newer and is something that we really like using here when we compile software for folks. And just to give you a quick taste, they're very similar, but there are some important differences. When you compile some software, you're going to create an ELF file for that executable. And it's pretty common that that ELF executable will need some shared libraries to function properly. Shared libraries are libraries that aren't compiled in when you run the compiler. Rather, they get loaded in when you run the program. RPath and RunPath will both help the operating system find where those shared libraries are. RPath will specify a path of places to search on the file system for those shared libraries, and it will try loading from those locations first. If it can't find any of them or some of them, it will look for those remaining shared libraries in LD library path. RunPath is very similar, it's just the reverse order. They're going to come in, our RunPath is going to come into play after searching LD library path. And that little change is super helpful. It means that we can override things if we want to with LD library path, and LD library path won't get overridden. So that's a super cool feature. Highly recommend using that. Let's talk a little bit about how this might work in practice. So this is a toy example here with program 1. Program 1 has some shared libraries it depends on. So in this case, program 1 requires libmpi, it requires libz, it requires libtiff, and it requires libxml. And in particular, libtiff and libmpi, there are certain versions that it requires. Libtiff, it looks like we've got a requirement on version 5, and libmpi, it looks like we've got a version requirement on 12.0. That's just the suffix there. That's the convention on Linux. And if we just have program 1, this is totally doable. We can get all of these dependencies going. And since we don't have any other programs to worry about, it's just super simple. We can install those shared libraries, no chance of conflicts. Well, let's imagine that this is a system that's like the supercomputer. It's not a personal computer. It's a computer that a lot of different users use. And so maybe there's a different user that wants program 2. And program 2 is very similar to program 1. In this case, they all share the same shared libraries, but there's some important differences. So program 2 also requires libz and libxml, but it requires a slightly different version of both libtiff and libmpi. In particular, program 2 says that it requires version 5.4 of libtiff, and that means that it's probably compatible with program 1. Program 1, if you recall, requires libtiff version 5. And so it's likely that version 5 and version 5.4 are compatible. It looks like, though, that program 2 requires libmpi.so.40, so version 40 of libmpi. And that's probably not something that's compatible with program 1 because program 1 required version 12.0. And so you can see here that if we want different research groups with different software that often requires different shared libraries, that environment modules might be helpful here. So just to reiterate, the supercomputer serves over 1,000 different users that are all active right now. And each of those users is part of a research group that's going to be doing completely different computational workflows and going to be using completely different software. And unfortunately, it's pretty common to see situations where that are not very far different from that toy example there, where different software from different research groups is fundamentally incompatible. So environment modules are going to help us solve these problems and going to help us get all of the software from the different research groups to play nicely and to coexist peacefully. And it's going to do that by setting up the right environment variables that the linker needs to load those shared libraries in. It's also going to set up other environment variables that are program specific. Programs sometimes need those to function properly. And like I mentioned before, it's going to allow different versions of programs and libraries to coexist peacefully on our systems. So now let's talk about how to use the module system on the supercomputer. The first thing that you might be interested in is how to find modules to load. So here's a group of some commands that are related to that idea. The thing that a lot of users will get the most mileage out of is module avail. So if you do module avail Python, for instance, you'll get all of the different versions of Python that are available on the supercomputer. Some modules have some prerequisites that need to be loaded first. So that's where module spider comes in. If you do module spider and then the module name and maybe even a slash version name there, it will list the different prerequisites that need to be loaded and what order to load them in. Module what is and module help are very similar to each other. They both give short descriptions about the module. They're not always available though, because a human has to go in and write these. And we sometimes forget. So just keep that in mind that that's not always available. Another helpful command when finding modules to load is the module keyword command. If you do module keyword and then a search key, it will search all available module files and match if the key is in the name, in the what is, or in the help. So let's demo some of these for you. I'm going to switch the screen I'm sharing here, and I'm going to share my terminal. Let's see if Zoom will be happy with me. Cool. So I think that my terminal is showing now. Hopefully that's the case. And so I'm here logged in on the supercomputer. And so let's see what versions of Python are available. So if I do a module avail Python, you're going to see that there's a big variety of different versions of Python that are available. Maybe I'm most interested in the default.
Pardon me.
Yeah,
Brandon,
go ahead.
can you go bigger text?
Totally. Is that big enough here?
Yeah, that's great. Thanks.
Okay, thanks so much. It's hard knowing exactly what's being shown on your screen, so I appreciate that. So you can see here with this module avail Python, let me run it again and clear my screen here so that it will wrap nicely now that my text is bigger. So you can see here that there's a bunch of different versions of Python that we have on the supercomputer. The D next to version 3.6 reflects that that's the default version of Python that's available. And you can see here that the D over here, there's this module TensorFlow-GPU, that's TensorFlow version 1, and specifically version 1.3 here. And that D reflects that that's the default TensorFlow GPU version that's available there. We can also look at module spider. So I can see maybe I want to load Python 3.7, and I can do module spider Python 3.7 here. And that's just going to say that the module can be loaded directly, that there's no dependencies that I need to load. Other modules might be different, and the spider command will show that there's some other modules that will need to be loaded. We can do a module what is on GCC because I know that there's a what is there. So you can see that there's just some little information that a human has put there, the name of the module, the version, the URL, and a short description. But I do know for a fact that there is no help for GCC. So if I run module help GCC, there's no module specific help. So keep that in mind, help is not always available. And maybe I want to see all the different compilers that are available on our system. I can run a module keyword and run compiler here. And it should do a big search for all the different compilers that are available. So you can see that there's an old deprecated module called compiler_GNU, another deprecated module compiler_Intel, and then you've got the GCC and Intel compilers that we recommend. And we've also pulled in LLVM, which is another set of compilers, and PGI, which is another set of compilers. scons isn't a compiler, so you can sometimes see that the keyword command doesn't pull in everything. scons is related to compilers. It's a build tool. LAMPS is not really related to compilers at all. It's a molecular dynamics simulator, and we usually install it with MPI. So you can see here that LAMPS is getting a false positive for compiler stuff. Any questions with that so far? Okay. Zoom is not being particularly happy with me right now. So I hope as I switch my screen back that I don't lose everyone. Is my mic still working for folks? I just got a message from Zoom that
Yep.
it was perfect. Okay. False alarm then. Let's see. Cool. And are my slides loading again?
Yep.
Awesome. I had the same warning message come up earlier yesterday, and Zoom completely crashed for me. So I'm glad that we're still on here. I think, though, I don't want to tempt fate. So I was going to demo more stuff, and I can certainly try demoing stuff at the end. But if there's anything you want to see demoed, feel free to put that in chat, and we'll tempt fate at the end. And hopefully that works for everyone. So let's talk about loading modules now. So the module list command is something that I use all the time. Module list will print out all the modules that I've got currently loaded, and I can change which modules are loaded via the load and unload commands. So I can load a specific module with a specific version with module load. There's also a shortcut there. You can type ML instead, and that's just shortcut for module load. And we're talking about different prerequisites. So keep in mind that module load may complain at you. It may say that you need to load other modules first, and you can use module spider to figure that out. And if you want to just load the default version, you don't have to specify that, and you don't have to specify that slash. Module purge will clear out all of the different modules you have loaded. It's basically running module unload for everything that appears in module list. If you find that you're switching between different versions of a module, there's a shortcut syntax. You can do a module swap, and that essentially does a module unload and a module load for the new version of that module. And again, if you'd like to see any of those, we'll try doing some demos later, just so that we don't crash here. Another really useful thing that I don't know if everyone's aware of is that you can actually create lists of modules. So once I've got a lot of modules loaded up, I can run module save and then a name. And what I can do from there is I can actually do a module restore and then that name, and it'll load all of those modules up all at once. And that's particularly helpful if you're in a situation where you've got different collections of modules you want to be loaded. You can look at the different lists that you have saved via the save list command. There's an error in my slides there that I'll go back and fix after. There shouldn't be any list name there because it will just list all of the different lists of modules that you have saved out. You can delete those lists with the module disable command. And if you are in a situation where you're not really switching which modules you're using very frequently, you can actually just drop the list name, and you can do a module save there. That's also an error. That should read save and not save list. I apologize. And that will use the default save list. This will get loaded automatically the next time you log in. And because those are loaded automatically, those will be loaded for every job that you submit as well. we'll talk more about that in just a second. I want to just briefly talk about some frequently asked questions. So a lot of folks are using different software libraries that they install with pip or R, and other package managers. And this extra module, environment module system can be a little bit confusing in that context. So first of all, package managers that require root access like apt or RPM are not permitted for normal users. I don't even get to install different RPM packages, even though I work here. There are some language-specific package managers that are included in the language modules. For instance, if you're doing a lot of Python, you can do a module load pip, and you can use pip install -- user with the package name to install that. It'll install it locally to you. And so because we've got this system and it works great, it's native to those language-specific package managers, we don't have modules for things like NumPy, tidyverse if you're from the R world. You'll just install those on your own. Let's briefly cover how environment modules work with jobs. So I mentioned if you do that module save with the default or the blank, that those will get loaded in every time you log in, and those will get transferred to your jobs. This is the mechanism by which it gets transferred to those jobs. So jobs automatically inherit all of the environment variables that they're submitted with. You can see this in action. That's why you don't have to load modules that you have loaded up when you submit work to the supercomputer. But you can also load modules from within your job script. One thing that we actually recommend for users, if they're sharing different job scripts with multiple users, maybe inside a research group and maybe outside, is that sometimes it can be helpful to not rely on the defaults that different users have set. So it's easier to debug if you run a module purge and then explicitly load all of the modules you want. In particular, it prevents it from working for one person in the research group and then not for other individuals in that same research group. That can be a little tricky, nuanced thing where some of the default behavior can get really nice, and you might not think about that at first. The last thing we want to talk about today before we get to some questions is that you can actually write your own module files. You don't have to rely on us to install things centrally, and that's not the only way that you can have module files. So the first thing you'll want to do when creating your own module files is you'll want to figure out where to put them. So you'll have some path to where you want to store them. We recommend a file sharing group if you want to share these with your research group. And then what you'll do is you'll create a directory with the name of the program or the name of the module you want to write. From there and underneath that directory, you'll have some version name, and it will be a Lua script. We'll show you an example here coming up. And you can have multiple different versions under that directory. You can have multiple different module names, those different module name directories. And that essentially is the same process we use for centrally installed modules. From there, though, you'll need to tell the module system where to find those extra modules. You can do that by running module use and then the path to your module files. And that's a great thing to consider putting in your bash profile or bash RC. The normal module commands that we've discussed previously will now show all of those centrally installed modules you had before and your specific personal modules. It can get a little bit tricky to figure this out. If this is something of interest to you, feel free to contact us and open a support ticket. Let me just show you an example module file here. So this is a real one that's currently loaded on the supercomputer. This is actually how I knew that we would get something back from what is for GCC, because this is the exact module file that exists. And GCC in particular is a little bit of a complicated module. So this is a good case study to see some of the different features that are available. So you can see that there's those what is lines at the top of the module file. Those what is lines are going to get printed out to the user when they run module what is. The family line is really interesting. So we were talking about some different programs that would have incompatible libraries. And not only can those happen within a specific program, so like maybe Python 2.7 is incompatible with Python 3.8, but that can happen across different modules. So in particular, you really shouldn't be mixing compilers. That can cause all sorts of problems with your environment. Not only that, but then it's really confusing to figure out which libraries are getting compiled in and which compilers are getting used. So we don't want to have any mixing there. So the family compiler will force the module system to only let you load, one compiler module. So all the different compiler modules will have that same line in there, and it will error on you if you try and mix those. The local prefix bit is just Lua. It's saying that there's a variable called prefix, and it's a string, and it's got that little path in there. And we'll use that in some of our following commands here, but you don't have to. That prepend path, is going to look at those environment variables. So for example, path, man path, and LD run path. And those environment modules are very special. They have a format of a file path. So some slashes, some letters, those kinds of things. And then they're separated with colons. So for example, path, we need to make sure that the compiler is available to different users. So you can use it with the GCC or G++ commands. So we're going to put that into the path. We're going to prepend it. And so we're going to take /apps/gcc/8.3.0/bin. That's what that prefix /bin is doing. It's concatenating those strings together. And we're going to prepend path. So path will now say /apps/gcc/8.3.0/bin, followed by everything that it had before. And we're going to also do that with man path. We're going to put all the manual pages for GCC that exist under /apps/gcc/8.3.0/shared/man. We're going to put that into the man path and prepend that. And we're also going to set up the run path so that we encourage folks who are using environment modules to and compiling their own software to use run path there. And so we'll use /apps/gcc/8.3.0/lib64, and that will get prepended to LD run path. Not every environment variable works like that though. And so the generic commands for different environment modules is going to be the push env command. So we're setting up cc to be equal to cc to be equal to gcc, cxx to be set to g++, and fc to be g fortran. And those will get undone when the module is unloaded. So that's an in-depth, good case study that GCC requires a lot of work to get the environment set up properly. And so this example should cover about 95% of different use cases if you're interested in writing your own module files. Now that that's over, want to make sure we address any questions first, and then if there's anything you'd like me to demo here, I'll try switching my screen and hopefully Zoom won't crash, but wanted to make sure we opened it up for some questions here. And again, if you've got a question, feel free to unmute yourself and ask verbally, or feel free to drop it in the chat there for Zoom. Cool. Well, it looks like there's no questions. So thank you so much for coming. If you need to get in touch with us, feel free to shoot us an email at rcsupport@byu.edu or open a support ticket on our website. Thanks for coming. Hopefully, you'll be able to get a good sense for environment modules and that'll help you be super productive on the supercomputer. Thanks so much.